Two identical capacitors of 12 picofarad each are connected in series across a 50 volts battery. Calculate the electrostatic energy stored in the combination. If these were connected in parallel across the same battery, find out the value of energy stored in this combination. Okay, first we will try with the series connection. These are two capacitors connected in the series. That is, one is a 12 picofarad, another is also in the 12 picofarad connected in the series, and the volt here it is a 50 volts. Okay, we know the series, that is in the series, that is equivalent capacitor is equal to, that we can find in like this, 12 into 12 divided by 12 plus 12. So, which is equal to 144 divided by 24. Then, answer is 6 picofarad or 6 into 10 to the power of minus 12 farad. Then, energy stored U is equal to half CV square, that is equal to half C is nothing but the 6 into 10 to the power of minus 12, and V is 50, V square is 50 square. We get the answer 7.5 into 10 to the power of minus 9 joule. Energy is in terms of joule. And the charge drawn, that is a Q is equal to C equivalent into volt, that is equal to 6 into 10 to the power of minus 12 into 50. The value is 0.3 into 10 to the power of minus 9 coulomb. This is the charge. And if I am going to connect this one in the parallel, then equivalent capacitor, that value is 12 plus 12. C equivalent is equal to 12 plus 12, that is equal to 24 picofarad or 24 into 10 to the power of minus 12 farad. And energy is equal to half C into V square, that is equal to half into C, that is a 24 into 10 to the power of minus 12 into 50 square. The value is 3 into 10 to the power of 3 into 10 to the power of minus 8 joules, or we can write this one as a 0.3 into 10 to the power of minus 9 joule. Because here we define this one in terms of minus 9. For the comparison, it is very easy. And charge Q is equal to C equivalent into V, which is nothing but 24 into 10 to the power of minus 12 into 50. This becomes 1.2 into 10 to the power of minus 9 coulomb. If connected in the series, 0.3 into 10 to the power of 9 coulomb. If connected in the parallel, 1.2 into 10 to the power of minus 9 coulomb.